welcome to the deep dive. If you've ever had a medical procedure held up, well, there's a decent chance the real culprit was the slow manual process behind healthcare intake and prior authorization. It's just notoriously clunky. And the problem isn't really the rules themselves, it's how fragmented everything is. Staff are hopping between systems constantly. You've got the EHRs, then countless different payer portals, emails flying in, sometimes even paper documents. All that juggling, it just invites delays and mistakes happen, which isn't great for patient care.
Exactly. And I think for a specialized audience like yours, the fact that prior auth is slow isn't news. The real question is, how do we tackle that fragmentation? So our mission today is to look closely at ZAPTEST, specifically how they approach automating this whole workflow to, actually deliver care on time and cut down those errors by managing all those different systems.
Okay, let's get into that core challenge then. You have, dozens of different payer portals, internal systems, and their interfaces are changing all the time. So how does something like ZAPTEST cope with that? How does it avoid needing constant manual fixes every time, say, a submit button moves? Sounds like it could break easily.
Right, and that's where the resilience has to come from. So first, they capture the workflows, the processes into reusable bits like modules. But the real key, the proprietary tech piece, is this combination of AI plus computer vision. See, old school automation often breaks if screen coordinates change. ZAPTEST's tool aims not to rely on those fixed coordinates. Instead, the computer vision looks at screen elements based on what they do, their function, their context. So let's say payer A updates their portal, moves the attached document button way over to the other side. Well, the automation script ideally doesn't break because the AI understands I need the attached document action, not I need the thing at pixel XY. That makes a huge difference for stability.
Okay, that resilience part makes sense now. So let's talk about running across different systems. ZAPTEST uses this one script T idea, basically one script that works across all these different places. Is that just slow UI automation, like clicking through screens? Or is there more to it? A mix?
Oh, it's definitely a mix, and it really needs to be both. API calls, always faster, always better if they're available. So the script uses APIs whenever it can. But the reality is a lot of payer systems, they just don't offer solid APIs for every single step in a complex prior auth workflow.
Right, so you're forced back to the screen sometimes.
Exactly. And when the tool has to interact directly with the user interface, that's where the computer vision component really takes over the UI automation part, doing it reliably. And it's not just the core tasks, they also automate those messy side jobs, like pulling data from unstructured documents or handling emails to truly cover the end-to-end process.
Okay, so bringing it back to the listener's organization, what does this kind of adaptive single script approach actually deliver? If it's truly resilient to change, what are the tangible benefits? For, risk, the bottom line.
Well, you definitely get the immediate wins, faster approvals, fewer errors, that's clear. But I think the bigger strategic advantage is genuine scalability. Think about it, instead of trying to manage, say, 50 fragile little bots, each needing updates whenever a payer tweets their website.
Which must be a nightmare.
A total nightmare. Instead, you're managing one script that adapts, that lets you handle much more volume without needing to just throw more people or maintenance effort at it. And compliance gets a boost too, plus audit readiness. Because that whole multi-system process is run by one traceable script, the system automatically logs every step. That gives you an instant audit trail, much cleaner than trying to piece it together manually from paper or screenshots.
Yeah, that directly hits the original pain point we talked about, getting away from that chaotic, manual system hopping and towards one cohesive, adaptable script that seems key to cutting delays and keeping patient care on schedule.
Precisely. And think about this for a moment. When a tool can use AI and computer vision to adapt almost instantly to UI changes, instead of waiting weeks for someone to rewrite code, well, the potential for deploying this stuff fast is huge. And that speed translates directly back to a better patient experience, getting care delivered on time. That's ultimately the goal here, right? Something for you to consider until our next deep dive.